In this video, we're going to learn how to prove triangles similar. Fortunately, this is a much easier topic than proving triangles congruent. There are a few different methods for proving triangles similar, but in this class we will only worry about the easiest one because the others come up very seldom. You will not be responsible for knowing what they are. So how do we prove triangles similar? Is there something like an SAS or an ASA or something like that that works for similarity? And the answer is yes, and it's very simple. The way we show that triangles are similar is we show that they have three pairs of angles that must match. So if I can show that these three, you have one pair, two pairs, three pairs of angles that match. If I can show that, then that guarantees that these triangles have to have the same shape, that they are similar triangles. So this would prove that triangle ABC, if I match up these, if I name the angles in this order here, I have to name these angles in the same order, so it would be triangle XYZ. And so we could call this AAA and then put a little similarity after it to remind us that this is a similarity condition, not a congruence condition. But it gets even better, because remember that the angles of a triangle add up to 180 degrees, always, no matter how big or how small or anything. The angles of a triangle always add up to 180. So that means if I know this angle matches this, let's say these are both 60. And let's say I know these two angles match. Let's say these are both, that looks like it's around a 90 angle. Let's say these are both 90. Well, this makes 150, this has to be 30. And this makes 150, this has to be 30. So what this means, a consequence of this, is if I have two pairs of angles that match, the third has to match automatically. There's no choice. Which means I don't really need to do all three pairs to guarantee the triangles are congruent. All I need is two pairs. It makes my life a little bit easier knowing that I only have to show two pairs of angles are the same. The way we write up the proofs is very similar to the way we do it when we're proving triangles congruent. We're going to use flowcharts. Let me do a couple of examples. Here's my first example. So I'm given BE is parallel to CD. That's my only given. I want to prove the two triangles in this picture are similar. Triangle ABE, the smaller one, and triangle ACD, the larger one. So I need two pairs of congruent angles. So, and there are three pairs we could get fairly quickly. I'm going to show you one possible way to do this. One pair of angles that's the same is this angle A here, this arc here. This angle, this amount of turn, is an angle of the smaller triangle, and it's also an angle of the larger triangle. So I have this shared angle that's an angle of both triangles at the same time. That angle counts as one pair, just as it did when we were proving triangles congruent. This is a shared angle. The other is we have these parallels, and as we know from the last unit, parallels lead to congruent angles. In this case, I have this corresponding angles configuration here. Here's this F shape that I've told you to look for. And when I have this F shape, that these angles here, let me put a one tick mark on this to distinguish it, and this angle here, those are corresponding angles, and if these lines are parallel, these angles must be congruent. And that's it. The proof is essentially over except for the writing it down. I have one pair of angles, the shared angle, and I have a second pair of angles from the parallels, and that's all I need. So I write angle A is congruent to itself. It's the same angle. And I'll say angle, what is this, EBA is congruent to angle DCA. Ah yes, but when I use parallels to get congruent angles, I always like to put above it the parallels that I use, even though in this case it's pretty obvious because there's only one pair of parallels given. This is given, and then this is the corresponding angles position. Remember, if I complete the picture and draw the transversal here and both full lines, we're looking at this angle here and this one right there. So these are corresponding angles. Here's one pair of angles that are the same between the two triangles. Here's a second pair of angles that are the same. That's all I need. this means that the triangles are similar. I don't need to do the third pair. It will happen if two pairs are congruent. The third pair happens automatically without worrying about it. And I just write under here A, sim. I like to write sim to remind myself this is not a congruence condition. This is a similarity condition. One more example. A little bit trickier. So here again, I'm given one pair of congruent angles, PTN. That's this angle, PTN, and PFT. That's this angle. Those angles are congruent. And then I have to prove two of the triangles here are similar. And I didn't tell you deliberately which two. You have to figure out which two you can prove are similar. There are three triangles in this picture. There's this one here, then there's this other one, and then there's the triangle that is the entire picture. And not all three are similar. And you can tell this triangle here, which kind of looks isosceles with two long legs and a shorter base, has a very different shape than this triangle, which has two shorter legs and a longer base. They both kind of look like they might be isosceles, NFT and PNT. Doesn't matter if they are or they aren't. The point I'm trying to make here is you can see that those are not similar. And if you try to prove them similar, you're just going to run into a wall. It won't work. We have one pair of angles already between two triangles here. I need another pair. And the key here is this angle here at P is a shared angle for this smaller triangle, triangle PNT, and then the entire picture. If I ignore this middle part, that angle is a triangle for the whole big triangle, for triangle PFT. There, the double tick mark angle is an angle of triangle PFT, and the double tick mark angle is an angle for triangle PTN. So, and then of course this is an angle of triangle PNT, and this is an angle of triangle PFT. And so that's my two pairs. This shows a feature that happens very commonly with similar triangles, and that is we can put similar triangles in much more together in more complicated ways than we can with congruent triangles. Because they're different sizes, I can assemble them in more confusing fashions than with congruent triangles. It can be more difficult to see that this triangle is similar to this one. It's usually when you look at a picture with congruent triangles, you can say, oh yeah, these triangles look like they're going to be congruent. Here it's not obvious, even with the givens, that this triangle here is similar to this larger triangle. But we have enough information. Remember, all we need is two pairs of angles. One pair is the pair that was given. The other pair is this pair at P, which is it's an angle of the smaller triangle at the top, and it's an angle of the big triangle PFT. And so that's going to be my AA sim. One last thing here that will become critical with the next lesson. You have to get the correspondence correct. Even more so than with congruent triangles, with similar triangles, you have to make sure that when you write your similarity statement, the order that you choose the letters for one triangle and the order you choose for the other triangle reflects the correspondence. Because we're going to lean very heavily on this for the same reason I was talking about briefly, because we can put these triangles together in very confusing fashions, and it can be hard to track, wait, what corresponds with what? This statement here will help us keep track of what corresponds with what. Fortunately, it is easy to do this if you remember to do it. You just have to match up the angles. We're always using congruent angles here. So let's name this small triangle here. Let's call it PTN. So we just look at the tick marks. Angle P in the little one is marked the same as angle P in the big one, so those will correspond. Angle T in the small triangle matches angle F. They're marked the same in the big triangle, so T is going to correspond with F. Therefore, angle N in the small triangle is left to match, that's the unmarked angle here, that's going to match the unmarked angle T in the big triangle. Notice, angle T in the small triangle is marked. That's the one tick mark angle that matches this one there. But angle T in the big triangle is unmarked. There's no mark that goes all the way through from this to this. So this angle N here, which doesn't have a mark, so I just put one down there, which doesn't have a mark, is the angle that matches this angle here. So the angle N in the small triangle is it matches the angle at T in the larger triangle. So writing similarity proofs is pretty straightforward, except you have to be careful to get that correspondence correct, because it can be trickier to see how things match up.